गुड इवनिंग बच्चों, गुड इवनिंग बच्चा लोग। आई होप वी आर लाइव। Everybody, please be active in the chat box and let me know, am I clearly audible and visible to everyone? My voice is crystal clear or not? Yes, all good. Chalo. So today we will be talking about another beautiful chapter, which is balancing. What balancing we are talking about? We are talking about balancing of some unbalanced forces. There are some forces, dynamic nature ka force, which is acting in your machines, and that dynamic nature ka unbalanced force, if it is not properly taken care, so it is going to create forced vibration, and this forced vibration is something which will remain in the system until your machine is switched on, until your moving parts, rotating part or reciprocating part, whatever is creating the unbalanced force, until your machine is running, this unbalanced force will keep on acting and it will keep generating force vibration. Your machine will be subjected to huge amount of vibrations, and because of these vibrations, running life of your system is going to decrease. And I don't have any problem why my life or running life of the system is decreasing. I don't have much problem with that. The major problem is, at the one hand, running life is reducing, and on the other hand, whenever the system is going to fail, the system is going to show fatigue failure, and fatigue failure is a very dangerous phenomena. Why? Normally, whenever something is going to fail, so I am expecting that it must show some sign before the failure, so that I can be aware ki, be cautious that this thing is going to be failed. But if something is subjected to fatigue failure, so machine will keep on running, and because of the vibration, system will become slowly internally weak, and all of a sudden, from the outer structure it is looking good, it is looking fine, but internally it has become so weaker that during its running condition at 2000 rpm, 3000 rpm, while doing this heavy motion, the system will break down. Suddenly it will break, it will show brittle failure. Something which is moving at this high speed, if it shows brittle failure, if it breaks, you can just imagine that what kind of deadly results it is going to have. Imagine kariye, if you are moving in a car, inside the car, some parts, rotating parts, reciprocating parts are there, and if during the running condition it fails, it is very dangerous. Not only loss of this car, not only monetary loss, it can also cost, it can also cost life of somebody. So it is very dangerous even for the human life also. So that's why it is very important to balance unbalanced forces. So I hope we have got a clear idea that what we are balancing and why it is so important. One by one, let's talk. One by one, let's talk that what are the things which are going to create unbalanced forces. Sir, it has been seen that unbalanced forces can be generated because of either rotating parts or reciprocating parts. So this unbalanced force may be due to rotating masses. By machineries, there are some parts which are going to have rotation wala motion, and there will be some parts which are going to have linear motion. We call it as reciprocating motion. So due to reciprocating masses also, we may have some unbalanced forces. So there are some, elements, some links which are going to have general motion. We have seen general motion is also a combination of rotation plus reciprocation. So I will see what rotating masses can cause, I will see what reciprocating motion, what linear motion can cause, and then whenever we see some part which is doing combination of this, so I can that mass, I can convert that mass mathematically into a 2-point masses system, dynamically equivalent system, whose one mass is going to have rotation, whose one part of the mass is going to have linear motion. So this is a mathematical phenomena. It means ki rotating masses ke effect if we have understood, reciprocating masses ke effect if we have understood. So if we have something, any mass which is having both the motions, general motion, combination of linear motion and rotation, so I can also solve this. It will include some more mathematical circles, but I can also solve this. So ultimately we have to focus on rotating masses and reciprocating masses. So unbalanced forces can be created because of both these things. Let's focus first of all on if we are having unbalanced forces due to rotating masses. Balancing of unbalanced forces which are developed due to rotating masses. Acha, rotating masses, we may have two situations here. Your rotating masses may have, we may have a situation where multiple masses are rotating on the same plane. Masses rotating on same plane. First situation. We may also have a situation where masses are rotating on different planes. We will treat both these situations differently. We may have masses rotating on different plane. Try to understand. First of all, let's talk about if masses are rotating on the same plane. First situation, if masses are rotating on same plane, try to understand when this kind of situation will arise. What are the examples of masses rotating on the same plane? For example, suppose if I am talking about I have a cooler at my house. So cooler may we have that exhaust fan. Fan may we are having 3 blades. Fan may we have a shaft. On that shaft we have 3 blades of the fan. Your ceiling fan which is at the top. Here also at any shaft we are having 3 blades attached to it. So all 3 blades, you can treat this as that we are having a shaft, and the shaft is mounted on some bearing. This is the shaft. This is the bearing. And on this shaft we have one blade like this, another blade like this, another blade like this. All these 3 blades are rotating at the same plane where they are rotating. So first example I have given, and all these 3 blades, one blade ka center of mass is here, another blade ka center of mass is here, another blade ka center of mass is here, and everything is rotating on the same plane. Different masses, same plane when they are rotating. We can have this kind of situation, or we may have another situation that for example, if I am having some gear, I am having some pulley, I am having some flywheel kind of thing. So how that looks, sir? We can have a flywheel. Sir, suppose this is the flywheel. This looks like this. So flywheel ka center of mass must be, whatever rotor I have, its center of mass must coincide with the axis of rotation. This is my intention whenever I make any rotating mass. So while manufacturing, my intention was that design things in such a beautiful symmetry that center of mass of this rotor is at the axis of rotation. But what if I could not manufacture? I can design it. Theoretically, I have designed ki try to maintain the symmetry, and center of mass will be at the axis of rotation. But manufacturing facilities have their own limitations. You will produce this thing by maybe casting, maybe metal cutting. So it's not necessary that designer has said that please make a perfect circular disc, but due to casting manufacturing limitations, you cannot guarantee that whatever you have made, it is perfectly circular in shape. Or who is going to take guarantee of this, that whatever molten metal you have poured, it has been evenly distributed? Maybe there are some gas holes and some defects are there. So whatever may be the reason, maybe situation is in such a way that center of mass, which was supposed to be exactly at midpoint coinciding with the axis of rotation, it is not coinciding now. It is somewhat away from the axis of rotation, eccentric. Intentionally I am not providing some distance, so I will not call it a distance. I am saying that it is eccentric. Eccentric means it was supposed to be at the center axis of rotation, but by mistake, by error, it is a little distance apart from it. Eccentric का मतलब होता है eccentricity is very very less. So your center of mass is not at the axis of rotation. Axis of rotation is this, sir. Your axis of rotation is passing through the bearings. On this axis I was expecting my center of mass to be, but my center of mass is suppose a little here. This is my mass m. Let me make it with yellow color. Whatever rotor I have, its center of mass is here. At how much distance? At some, from the axis, it is at some e distance. Very small thing at e distance. M mass is at e distance. So what are the examples what I have given you? We may have gears, we may have flywheel, fan, which I have given you the example, exhaust of the cooler, all these things. What is common in all these things? I am taking all those examples where diameter wala dimension is quite high, quite big as compared to this length wala dimension. So all these examples whatever I have taken here, diameter wala part is very very big as compared to its longitudinal dimension. You can see this, sir. Even if you have taken this flywheel, so flywheel ka diameter is quite big as compared to its length wala part. So length is negligible. I can imagine that we are having same plane pe masses are rotating. So here we are having only one mass, no problem. If I'm talking about exhaust fan or this ceiling fan ka blade, so we are having three blades, three different masses. Each blade is different part. So each blade's center of mass is eccentric from the axis. So collective center of mass, I was expecting that it should be at the center of at the axis of rotation. Right? Exhaust fan mein we are having three blades. So all these three blades ka collective center of mass must coincide with axis of rotation. If I failed to make such a beautiful thing, mass is eccentric now, what problem will arise? Problem is that when this setup starts rotation with omega angular speed, what happens? Omega, say if you are rotating, so e distance pe we are having center of mass m, so its centrifugal force will generate like this. What is the centrifugal force, sir? Centrifugal force is m e omega square, and that is going to be huge. Why? If your mass is quite heavy, even if eccentricity is very very less, sir, by error, this is error, very small distance, 1 mm, 2 mm ka eccentricity is there. Beta, your mass is heavy, if your mass is heavy, or if your omega is quite big, whatever speed पे you are rotating, if that speed is quite big, देख रहे हो, you can see, sir, square is here. So at one hand you are having speed is high, and on the other hand in the formula we are having a square of that. So force ka magnitude is going to be very, very high. And this force, whatever you are seeing, it is not constant force. Its direction is continuously changing. Magnitude is constant, but the direction is continuously changing. This force is looking upward right now. But when this, because of this omega rotation, center of mass moves here. So next time, this force will be here. And then mass again moves. So wherever mass goes, centrifugal force will be in the radial direction. Imagine कर पा रहे हैं, we are having a shaft, and shaft पे we are having a mass which is rotating. So wherever this mass goes, force moves in that direction. So force is dynamic in nature. Its direction is continuously changing. बात समझ में आ रही है? So this kind of force is going to create unbalanced forces, and those unbalanced forces will be from this system. It will be transferred through this bearing to this surrounding. Imagine करिए, if I am talking that this is your some part of the engine or motor, or even your cooler में I have exhaust center of mass was a little eccentric. So because of that, when cooler moves, it creates unbalanced force. Exhaust creates unbalanced force, and that unbalanced force from the exhaust gets transferred to the cooler, and my entire cooler body is going to vibrate. I want to reduce or eliminate that vibration. बात समझ में आ रही है? How we can do this? We have to balance things properly. What is the meaning of balancing here? Sir, balancing का मतलब है कि unbalanced force is being created. So to eliminate this, on the same plane, if you can connect one mass, same plane, if you can connect one mass, what is the mass? I am calling it as balance mass. This is balance mass. Some MB mass we have connected here at some distance, RB distance, balance radius. At what radius? Some balance radius distance we have connected, and because it is connected to the same shaft, so it will also rotate with omega speed, and its centrifugal force will be in this direction. Can you feel this force? Just opposite direction mein, opposite to this, these forces are going to get cancelled. Resultant force is going to be 0. So ultimately, when I'm saying that please balance this, so what I'm trying to do, I'm trying to do summation of forces equal to 0, making summation of forces equal to 0, and ensuring this is actually what we are doing. We are actually ensuring center of mass at the axis of rotation. If your mass was a little distance, E distance पे, R distance पे it was there, so opposite side में I have connected another mass which makes this collective mass का center of mass at axis of rotation. So center of force 0 ensure करना. I can also alternatively I can say, or this, or I can also write it as ensuring center of mass at axis of rotation. I hope this is clear to everyone. So whenever I say some masses are rotating at in the same plane, please make this system balanced. What is the meaning? Ensure summation of forces 0, centrifugal forces ka summation 0, or ensuring center of mass at axis of rotation. These two things are nothing but same. Getting my point? And how we can achieve this on the same plane? Just by adding one mass, that's it. We may have multiple masses, sir, like cooler ka example. Exhaust fan mein we are having 3 blades, we are having 3 masses, they are rotating on the same plane. And if this system is not balanced, so somewhere on this setup I will connect a balance mass and my work is done. Only one balance mass on the same plane is enough to achieve complete balancing, and this is technically also called as static balancing. It is called as static balancing. ensuring forces conservation 0 is called as we are doing static balancing. Once system is statically balanced, I will say this system is completely balanced. No other unbalanced force or moment is there. How we do this mathematically? Simple सी बात. How we do this mathematically? Imagine करो. Suppose we are having a shaft which is mounted on some bearing at some plane. What is the plane? The plane which I am talking about is this plane. I am talking about this plane. I am talking about this plane. Okay, this kind of situation we are having. Y-axis and this is my x-axis. X-axis, this is my y-axis. Careful. On this shaft, I am having so many masses. How these masses are looking? These masses are on this shaft. I have one mass is at this distance. One mass, m1 mass. Sir, this is my m1 mass, r1 distance पे, and it is at some angle, theta1 angle. Suppose I have on the same shaft, same plane पे, I have another mass. This is m2 mass. This is your m2 mass, r2 distance पे है, and it is at some angle theta2. Or we are also having one more mass, m3 mass. Let me call it m3 mass. This is your m3 mass, r3 radial position पे, and it is making theta3 angle. And can you see all angles I am taking from positive x-axis से, from the positive x-axis anti-clockwise direction में all the angles I have taken. Clear है? Examination में to confuse you, they can also give angles that this angle is 30 degree, this angle is 60 degree, and this angle is something 120 degree. They can also give it like this. So whatever angles they have given doesn't matter to us. I have taken, for the calculation purpose, I have taken my angles theta1, theta2, theta3, for all the angles from positive x-axis in the anti-clockwise direction. These, fine details everybody must remember. Yes, beta. All the Parakram batches में I'm going to take live. Abhi recently we just have finished, na? Recently we have finished. Okay, so maybe in future, repeated theory of motion will be, at the end of the year. And one person is saying, sir, can you take more PYQs? I have included PYQs. So don't worry. Wherever it is needed, some question to explain the concept, I have, already taken the PYQs. Yesterday for flywheel, we have seen some PYQs also. Okay? Everybody is comfortable till this point? Chalo. So whatever I have shown, this is 3D view, and to see this even more clear, let me show you another view of this diagram. Sir, if I show you this from side view, so you will be able to see the clear picture. What are the angles between the different masses? Can I draw? Sir, this is my xy plane. This is x axis, y axis. So whatever plane I have drawn, this is your xy plane. This is your x axis, y axis. This is your x axis. This is your y axis. How masses are there? Sir, we are having one green color ka. And where is this shaft? Shaft is here. This is the axis of shaft perpendicular to this plane. And on this shaft, I am having one mass m1. Here r1 distance पे we are having another mass m2 r2 distance पे I am having another m3 mass at some r3 distance पे. So we are having these three masses, m1 mass r1 distance पे, which is at some theta 1 angle. This is the even more clear orientation diagram. Clearly I can see. Then we have, this is m2 mass r2 distance पे, and it is at some theta 2 angle. And then we have theta 3 angle पे m3 mass at r3 distance. Clear hai baat? Now, how do I balance this entire setup? First of all, examination mein how they can ask questions? They can ask questions like, first of all, tell me whether this system is balanced or not. How do we check this? Sir, if this system is balanced, so whenever this setup rotates, so centrifugal forces will be radially outward direction mein, radially outward direction mein, radially outward direction mein. So all these forces, this force, this force, this force, if their total summation is 0, I will say that this system is totally balanced. Its center of mass is at the axis of rotation. If it is balanced or not, how can I check this? Like this. If it is not balanced, so whenever you take resultant of this, all these forces, it will not be 0. You will get some resultant unbalanced force, and that resultant unbalanced force, how we can get? You can take components, है ना? These are the forces at some different angles. So you can take all these forces का x component, x component, x component, all x components का summation. You can find out what is the summation of forces in x direction. You will get some value. Summation of forces in y direction. All these forces we have, take y component, and then we can find out what is the total unbalanced force. Unbalanced force is under root x component, we just have calculated, square plus summation of y component square, something like this. बताइए बेटा. Sir, which branch to choose for industrial production or mechanical for gate preparation? I think mechanical has more options, है ना? Job opportunities, mechanical has more options, more opportunities. Even for the sake of admission, mechanical has more opportunities. So even many people who are doing their BTech from some related branches, that my BTech is in automobile, even they choose mechanical as an gate ka paper. Parakram maybe if it is showing recording, so it will be my recording. We just have finished same Parakram batch which is going on. I just have finished theory of machine, है ना? So you will get some one subject theory of machine is completed, so you will get rest of the subjects in live format, है ना? That's my idea. But if it will be, it must be in your planner. Whatever you have information, that will be in your planner only, है ना? If it is live, it will be taken by me. It is, if it is recorded, so whatever just I have finished few days back, 3-4 days back, I have just finished, so its recording will be available to you. Coming back to this situation, I hope everybody has got it. If question where they are asking, tell me what is the unbalanced force. So this is the process of finding out unbalanced force. If x component is coming out to be 0, y component is also coming out to be 0, unbalanced force is 0, that means this system is balanced. So what type of questions they can ask? Careful. They can first ask, tell me whether this setup is balanced or not, है ना? This system, if it is balanced or not. कैसे करेंगे? Calculate x component summation y component, take what these values are, and then we can find resultant unbalanced force. X component का square, y component का square. I just have written. First thing, sir, if this system is not balanced, then they can say कि balance it. If it is not balanced, then they can sometimes ask कि balance this. How do we do this? So if this is not balanced, if the system is not balanced, to balance this on the same plane, I must connect something. Where? I don't know, but it must be on the same plane. It may be here, it may be here, it may be here, it may be here. So at some location, I have assumed that to balance this entire thing at some RB distance, MB mass, MB means balance mass, RB distance, balance radius, I have corrected something, and its angle from the positive x-axis, its angle is given as theta b angle. Orientation is given as theta b. So just when I have connected this, entire summation has become 0. If it was not earlier 0, so after connecting this, everything becomes 0. Sir, likho jara. Summation of forces x component पे I am ensuring it to be 0. कैसे लिखना है? Centrifugal forces, sir, m1 r1 omega square cos theta, one component. It's cos theta component. m2 r2 omega square cos theta 2 component. And keep that in mind, sir. One student is saying, sir, its cos component is actually in this direction. Why you are adding this? Its cos component will be here. Its horizontal component will be here. So you must subtract these things. Why you are adding it? Beta, I am not taking this angle as theta. That's why I am taking angle theta, this one. So when you will take this angle ka cos theta, automatically it will become negative. है ना? So that's the beauty. When I am taking all the angles from positive x-axis in anti-clockwise direction, so I don't need to take care of whether it will be positive or negative. Automatically calculation में it will be adjusted. m1 r1 omega square cos theta 1 plus m2 r2 omega square cos theta 2 plus m3 r3 omega square. Everything is rotating with the same omega square cos theta 3, and all these, m1, m2, m3 masses, whatever forces they are generating, I have written the cos components. And the moment I connect here balance mass mb rb omega square cos theta b, the moment I have connected this balance mass, now this entire thing becomes 0. So from here, can I calculate what will be mb rb omega square? Or can I say, sir, this entire thing is equal to 0. So omega is common, take common, make it equal to 0. So omega square gets cancelled. So this entire equation further can be written as, if I don't write this omega, it doesn't affect me. Why? Because everything is rotating with the same omega. Getting my point or not? So can I write? I will get something mb rb cos theta. This thing I just have added. So I have got something summation of mr cos theta and take it that side equal to, I will get minus summation of mr cos theta, and similarly summation of forces in y direction I will ensure it to be 0, and from there I will get some mb rb sin theta b equal to minus का summation of mr all the sin thetas. क्या करेंगे सर? For writing this y component I will write m1 r1 sin theta 1 plus m2 r2 sin theta 2 m3 r3 sin theta 3 mb rb sin theta b equal to 0. So mb rb sin theta b is equal to this entire thing ka summation, take it that side, it becomes negative, so minus mr sin theta. So I have got these two equations. I have, this is equation number 1, equation number 2. With these two equations you can solve the question. कैसे solve करेंगे? Careful. How examination they are going to ask question? They will ask first thing, sir, if I equation 1 equation 2 ka just do square of this and add it, so what I'll get? This square plus this square, so mb rb square, take it common, inside I'll get cos square theta b sin square theta b, this is theta b, this is theta b. So cos square theta plus sin square theta becomes 1. So I am left with mb rb square is equal to this square plus this square. So I have one term minus ka summation of mr cos theta square plus another term minus ka summation mr sin theta square. I have got this kind of value. This is a square, so do both sides, take under root. So mb rb ka value is under root this square plus this square, है ना? Examiner क्या करेगा? Examiner will give any one value out of these two, mb or rb, any one will be given. कि tell me at this radial position I have to connect a balance mass. What will be the magnitude of that mass? You can calculate what is the mb, or they will give that 1 kg balance mass I want to attach. Tell me at what radius I have to connect this. So mb or rb, any one will be given, other will be asked. First thing, orientation कैसे निकालेंगे? How do I find out the orientation? Orientation के लिए you will write equation 2 divided by equation 1. So you will get sin theta upon cos theta. mb rb gets cancelled. Sin theta upon cos theta, this is tan theta b will be equal to this divided by this. So minus summation of mr sin theta divided by minus ka summation of mr cos theta. From here you can calculate what is the angle, at which particular angle you have to connect, and keep that in mind that these negative sign you don't have to cancel. Why? Because these negative sign are going to indicate about the which quadrant actually mass have to be connected. Sir, the numerator wala part, it is representing the sin theta wala part, y component. So this is representing y component, and this denominator wala component is cos theta, it is representing x wala component. So this is representing x component. What I want to say is, beta, that suppose if you are calculating your tan theta with one example, if suppose you are calculating tan theta and suppose this answer is minus 3 upon minus 4. So for you or for calculator, doesn't matter it is minus 3 by minus 4. You write it minus 3 upon minus 4, or even if you write this as 3 by 4, calculator will say, "Arey bhaiya, this is just 3 by 4 only." So calculator will give you the answers always of the first quadrant. Calculator will give you its some value, some theta ka value is, example ke liye, this is suppose 30 degree, 40 degree, some value they have given. 40 degree value the calculator has told you that connect something at 40 degree angle. Now 40 degree is somewhere here. This position have been told at this particular angular position you have to connect something. If this is your shaft, so you have to connect something here, but at this position or at this position, I don't know. That will be decided by these signs. Sir, y component is negative. Niche we are having x component, this is also negative. So y negative, x negative. This is x, this is y. Positive, positive. Negative y, negative y. So negative y, negative x. So y is also negative, x is also negative. It means we are at third quadrant. So calculator, although is giving this is third quadrant, although your calculator is telling you that 40 degree is the value, but I don't have to connect mass here. I have to connect mass at this distance here. So you have to tell me what angle. I will tell you this as my theta b. How do I get this theta b? Sir, 40 degree plus 180. Getting my point. I hope this is clear to everyone. So this sign is very, very important. Okay. On the other hand, suppose sometimes if you have done calculation and your answer is coming out to be something 3 upon minus 4. If your answer is coming out to be plus 3 upon minus 4, the upper this numerator wala component is positive, denominator wala component is negative. Plus 3 upon minus 4. So what does it mean? Sir, what does it exactly mean? If you'll simply ask your calculator what is the answer, calculator for the negative value, calculator will tell that's okay, answer is something negative, minus theta, minus 30 degree, है ना? But minus 30 का मतलब होता है this is your plus x plus y minus x minus y. Calculator has told you this value minus 30 degree means minus 30 degree like this. But whether mass is actually connected this side or this side, I don't know. Who will decide that? These sign will decide this. Although your calculator has given you this value minus 30 degree angle, but this upside numerator mein we have this y is positive. What about x? Sir, x is negative. Y positive, x negative. Which quadrant? क्या लगता है? Which quadrant? Y positive, x negative. We are at the second quadrant. So although your calculator has given you this minus 30 degree, but I will not connect at fourth quadrant. I will connect some mass here. Here. बोलिए, बताइए. Is this clear or not? I will connect mass here. And what angle I will give as an answer? Sir, from the positive x-axis, I will tell this as my theta b angle. Tell me in the chats if everybody is comfortable. Placement wise, if you are asking your question that I have given the gate, and after gate in some IIT I am getting a chance to pursue MTech. Whether you are talking about MTech or you are talking about BTech from these branches. Industrial engineering, if from the point of view of MTech if I am talking, so industrial engineering से IITs का placement is a little higher side पे, है ना? Pay packages are a little higher. Almost every IIT में you will find this track record. So I hope this is clear. What we have done here, if masses are rotating on same plane, they can ask you, tell me what is the unbalanced force का amount. This is how we can do this, है ना? Sir, unbalanced force, how much it is? Just take all this entire summation. Take this entire summation. This is x component. You have added something to make it 0. If they are asking, tell me just what is x component, y component, calculate this. Calculate mr sin theta summation. है ना? So x component just calculate how much it is, y component calculate how much it is. unbalanced force you can find out. Okay? Or sometimes they can ask you to do the balancing. This is how we are going to do this. Sometimes we may have masses rotating on different planes. Although from the point of view of gate, it is not that important. Why? Because questions here become a little lengthy. But I will give you a brief idea here. If masses are rotating on different planes, if masses are rotating on different plane, how first of all does it look? We may have so many situations where you find some rotors whose diameter and length they are comparable. Earlier whatever I have talked about those situations where flywheel ka diameter was quite big as compared to its length wala part. है ना? Ceiling fan, sir, diameter wala dimension is quite big as compared to its longitudinal dimension. है ना? So one dimension was ignored. But sometimes we may have situations where I cannot ignore the length wala part, and this kind of situation arises like if we are having, look at this, if we are having, this is a huge turbine rotor. Can you see this? Big shaft. On this big shaft we have, this is turbine rotor. First of all, imagine the huge size. It is so huge that a full adult woman is looking like a toy in front of it. So you can imagine the mass. In tons, it is going to have some mass. 10 tons, 5 tons, this mass, 5,000 kg. And where are the masses? Sir, at one plane, here, we have so many blades arranged. Okay. In next plane, we have so many blades arranged. In another plane, we have so many blades arranged. So different planes where we are having so many blades arranged. First of all, I was expecting that every plane pe so many masses are there and collective center of mass should be at the axis of rotation. I was expecting this, but due to manufacturing error, it was not possible. So in this plane, center of mass is from the axis of rotation, it is a little eccentric at some radial distance r. Different plane pe, in this plane, some whatever collective mass is there, it is at some radial distance. Then different planes pe, from the axis we are having different masses are at some distances. So this situation I can treat it as we are having different masses which are rotating on different planes. Sir, in this case, at least design point of view I can think ki symmetry is there and every mass should be at the axis, but due to manufacturing limitations it is not possible. And you have made all these blades by casting or machining, so ensuring that these 100 blades they must be exactly same, it is very next to impossible. Even if you have achieved this, every blade you are going to weld or connect with the help of some nut bolt. So after connecting this hundreds of blades, maybe because of the welding, maybe because of the nut bolt joints, center of mass is got disturbed. So there are so many various reasons because of which center of mass of this plane is a little distant from the axis of rotation due to manufacturing limitations. So here we will be having some eccentricities, not intentionally but error wise some mistake is there. On the other hand, sometimes parts ka design is in such a way, look at this, we are having crankshaft, a multi-cylinder engine ka crankshaft, and this huge crankshaft which I am showing, it is of a very big ship of this size, and a cargo ship, cruise ship I am talking about. So here we have multi-cylinder engine, and multi-cylinder engine ka crankshaft if I show, I have the shaft and design is in such a way that one crank is in this direction, another crank same shaft mein in this orientation, in inside direction, this one. So we have here design itself is saying that on one shaft we are having one mass this side, another mass this side, another mass this side. So this mass will be rotating on some plane. Sir, this mass will be rotating on this plane. This mass will be rotating on this plane. This mass will be rotating on this plane. So different masses are rotating on different planes. So what situations, what parts are there? Like we are having turbine rotor. We may have crankshaft of multi-cylinder engine. Crankshaft of multi-cylinder engine. All those situations where diameter, Wallah dimension, now you cannot say that it is quite big as compared to longitude. No. They are comparable. Is comparable with longitudinal dimension. I cannot ignore the length wala dimension. ठीक है ना? So we may have so many planes. One mass is rotating on this plane, another plane, another plane, another plane. So we may have 5-6 planes. Like in this case, I have shown you 1, 2, 3, 4, 5, 6, 7, 14 planes. है ना? So different planes पे we have some masses which are rotating. How that thing looks? Sir, there are two ways to balance this. Arey bhaiya, masses are just rotating now. So either you can do one thing, that in this plane, I can do balancing. That its center of mass should be at the axis. How we can do this? Sir, we just have seen masses pe some planes are rotating, same plane pe I will connect something to balance it. Next plane pe, every plane pe I will do the balancing. So if we are having 14 planes, 10 planes, so 10 plane pe 10 balance masses at some distances, some orientation I can correct. Individual planes ko I can balance. One solution is this: 10 balance masses are needed. On the other hand, doesn't matter how many planes we are having, just by adding 2 balance masses I can complete my work. How? Try to understand here. Suppose we are having one mass is rotating at this plane here. I have this m1 mass, another mass is here, m2 mass. This is my m1 mass, this is my m2 mass, r1 distance, r2 distance. Only 2 planes I have taken, and if this setup starts rotation with omega speed, careful. So what I was discussing, on some shaft, m1 mass, r1 distance pe I have, m2 mass, r2 distance pe I have, and imagine if they are on the same vertical plane, on this board only. Otherwise, it can be even more complicated situation. We may have one mass this side, another mass outside the board here at some angle, another mass like this. So orientation may be there. For the sake of simplicity, I have taken the simple example. So m1 mass r1 distance pe, m2 mass r2 distance pe. So when this setup rotates, what we are going to have, sir, you will be having its centrifugal force, its centrifugal force this side, its centrifugal force this side, and these forces I must ensure zero. I must ensure that this mass and this mass, their collective center of mass should be at the axis, है ना? So I have to check whether summation of forces is 0 or not. So forces go 0, I have to make sure. What is the technical name for this? I call it as static balancing. What I'm doing, I am doing static balancing. On the other hand, just ensuring forces 0 is not sufficient here. Why? Because these forces are also forming some moment. So I also have to take care that total moment should also be 0. This time I also have to talk about moments. And moments 0 ensure karna, this is called as dynamic balancing. Dynamic balancing. Static balancing as well as we have to do dynamic balancing. And another thing, sir, one thing doesn't ensure, one thing doesn't guarantee other. What does it mean? What do I mean? Sir, if I say we are having m mass r distance पे and here also m mass r distance पे, symmetry है. Sir, this kind of situation, even if we are having symmetry, that m mass r distance पे, same m mass r distance पे. So one thing I can say very clearly that, sir, this m mass from the axis m mass is at r distance, axis say r distance पे same m mass. So their center of mass is at the axis. यानी कि there will be no resultant force. Force is 0. Sir, this force downward direction में, this force upward direction में, forces are already becoming 0. It means this system is statically balanced. But even if this is statically balanced, this force, they are going to form a couple. Dynamically it is unbalanced. So I have to check for both individually, independently. One thing doesn't guarantee other thing. Okay, sir, if it is statically balanced, so it will be dynamically balanced. No guarantee. If it is dynamically balanced, it will not guarantee, static balancing. Individually I have to check, first thing. And how I am doing this, sir? To do this, what we can do for the balancing, here at two different planes, one plane pe I have connected some mass, some balance mass, MB mass RB distance pe, and another mass I have connected some here, some MB mass RB distance pe. This is MB mass RB distance pe I have connected. And what will happen now, sir? I'll be having centrifugal force this side, centrifugal force this side. In this situation, symmetry, same M mass, same MB mass, RB distance way, and I'll be having a couple where, sir, this force upside, downside. So I'll be having a couple like this, which will balance this force upside, this force downside. So they are forming a couple. This gets balanced. On the other hand, sir, what about the upper situation? What about this situation? Sir, in this case, I will say we are having this force seems a little bigger. If we have M2 mass, R2 distance quite big, so this force is small, this force is big. I must apply some forces, some masses, different masses, some mass this side and maybe some different mass this side. This is MB1 mass, RB1 distance पे, and this is MB2 mass, RB2 distance पे. And what orientation, that angle also I have to calculate. Careful. Exactly same fashion se we will perform everything. The only difference is here calculation will be a little lengthy. How it will be lengthy? Because when we are talking about only static balancing, same plane pe if we are talking, if masses are rotating on same plane, so MB mass I have to connect at some RB distance. So out of these two things, any one will be given. So one thing from here I have to calculate, and at what theta I have to connect, another thing I have to count this. So one unknown from here, one unknown from here. So I have two unknowns, and for these two unknowns, for this two unknown, how many equations I was having? I was having two equations. What equations we got? Sir, summation of forces x component 0, summation of forces y component equal to 0. From these two equations, you can solve these two questions. I hope this is clear. Two equations, two unknown, we can solve it. Now, when we are having masses rotating on different planes, what is the unknown? How many unknowns are there, sir? Two planes pe two masses I have to connect. So examiner will ask, tell me how much mass mb1 rb1 distance pe, and what is the angle theta1 theta b1, and mb2 mass different plane pe rb2 distance pe, and what is the angle theta b2. Out of this, anyone will be given ki mb mass at some distance, how much mass is to be connected. So out of these two, anyone is given. Other unknown is this. So one unknown, two unknown. Out of these two, anyone will be given. At this plane, 1 meter distance pe how much mass I should connect. So one unknown here and one unknown here. How many total unknowns? 1, 2, 3, 4. There are total 4 unknowns. And for 4 unknowns, I must know 4 equations, and those 4 equations will be from summation of force 0 say summation of force x component 0, summation of force y component 0. These two equations we have made. So we have got one equation, two equation. These are the two equations. And then making summation of moment 0, it will also give you two equations. Summation of moment x component 0, summation of moment y component 0. These are the two unknowns, the two equations further we have got. So total 4 equations I have got. 4 equations and 4 unknown. Simple si baat, simple si baat. It will be just a little more time taking, just little lengthy process. बताइए बेटा. Is this clear to everyone? ठीक है. Gate में they will mostly ask, masses are rotating on the same plane, how to do balancing. Different planes पे masses if they are rotating. So this kind of questions are rarely asked. Why? Because it becomes a little lengthy. On the other hand, sometimes they can ask questions if we are talking about reciprocating masses. They can also ask question on this. Now let me give you an idea how, if masses are reciprocating, how it will generate and what kind of unbalanced force, how it generates unbalanced force, and what is the nature of the unbalanced force. Now we are talking about balancing of unbalanced force due to reciprocating mass. Careful. And as an example, I am taking, suppose I have engine. Engine mein what do we have? We have, this is the crank, and from the inner dead center, crank has traveled some theta angle. Connecting rod looks like this. This is your connecting rod, and I have, this is the mass. Pin joint, pin joint, pin joint. Clear hai? Sir, this is the R distance, radius R, connecting rod ka length L. And this, suppose we are having this reciprocating mass M, piston which is doing reciprocating motion, this is mass M. Although, sir, what about this crank? Crank is also rotating, its mass can I consider? Yes, this has mass, but for the time being, just ignore this mass. Why? Arey bhaiya, rotating mass ko how do I balance? We just have seen. So if you want to balance this mass on this shaft, backside mein we will just connect something, it will be balanced, hai na? So for the moment I am ignoring this rotating mass. I have seen this. Now I am just trying to see only effect of reciprocating mass. Sir, how reciprocating masses के effect are getting transferred. This mass, your crank was moving with some omega angular speed and it has traveled some theta angle. It has traveled some theta angle. It is moving with some omega angular velocity. And at this time, I saw that mass m was moving with some a acceleration. With v velocity, with a acceleration, it was moving in this direction. ठीक है. M mass, a acceleration, say it is moving. So opposite to acceleration, I will be having some inertia force, pseudo force. Inertia force will be in this direction. Inertia force will be m into a. And whatever inertia force we are having here, this is going to have effect from here, transfer to here, and at the end, I'll get effect here transferred. Imagine kariye, I have this hand, and whatever force I am applying here, the same jerk, can you feel at the shoulder? Yes, sir. So whatever you are applying here, from all these links, it is getting transferred here at the shoulder. You can imagine this is the piston, we have this connecting rod, and pin joint, say I have the crank. So whatever you are applying here, that thing you can feel at the shoulder. Same logic I can use here without doing mathematical calculation. Physically you can feel it, that whatever mass is feeling force here, that will be getting transferred here. So I have inertia force this side. So inertia force will be here also. This side inertia forces I will be getting. And what is the inertia force? MA. Sir, acceleration we just have studied yesterday, or the day before yesterday, kinematic and dynamic analysis mein we have seen. I'll be having acceleration कितना होता है? R omega square cos theta plus something. MA will be how much? Sir, this unbalanced force, it will be M R omega square. Acceleration is R omega square cos theta plus cos 2 theta divided by N. Something like this. Open this bracket, I can write M R omega square cos theta plus M R omega square cos 2 theta divided by N. Can I write it like this? It means, can I say that this unbalanced force is actually summation of two components? Acha, can I write this N divided by N here? No problem. And if we'll see, what does it mean? Sir, some force into cos theta. Cos theta is just representing fluctuation. But theta will keep on changing. Cos theta ka value 0 से 1, it will keep on moving. So presence of cos theta or cos 2 theta is just representing that force is fluctuating. What is the amplitude of the force which is fluctuating here? So that is amplitude of the force is mr omega square. Here we are having mr omega square by n, and n ka value, which is L by R, this is large value, है ना? Generally, sometimes it is very very large. Large value का मतलब होता है of the order of 3, 4, 5, है ना, 6. Of this order, definitely it will be. Sometimes steam engines के case में it will be even very very large, 10, 15, 20 of this order. So can I say one thing? That sir, this component of the force, its amplitude is mr omega square. Its other component, its amplitude is mr omega square by n. Yani कि this component is quite big. It is 4 times, 5 times, even sometimes 10, 20 times smaller. So for us, it is very very important to balance this. If I want to ignore, I can ignore this. This is called as primary unbalanced force. Primary unbalanced force. And this is called as secondary unbalanced force. है ना? So let's talk about how do we balance primary unbalanced force. Sir, primary unbalanced force, gate में examination में they will ask question here. How much is the force? Sir, this force is mr omega square cos theta. Cos theta. Mr omega square cos theta. What about this force? Sir, why you are saying that this is unbalanced force? Sir, this is a dynamic force. What is the meaning of dynamic force? Whenever force ka magnitude changes or direction changes or both changes, force is a vector quantity. So either continuous change in magnitude or continuous change in direction, I will say this is dynamic force, fluctuating force. Sir, in this case, reciprocating masses की वजह से force will always be in horizontal direction. It may be this side or maybe sometimes this side, depending on acceleration, if it is this side or acceleration this side. Accordingly, inertia force will change its direction. It will be horizontal direction only, but maybe this side or maybe this side. Its magnitude changes. Sometimes cos theta ka value becomes 0. Sometimes it becomes 1. Sometimes it becomes -1. The force is sometimes here, this increasing, 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 then decreases, 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 and then changes its sign. है ना? So its variation is like sine cos wave. Clear hai baat? And because of this forces only, whenever you switch on your bike mein we are having a piston which is doing reciprocating motion, and because of that part I couldn't balance. I wanted to balance this completely, but somehow I will show you I couldn't balance it properly. Because of that reciprocating mass only, its unbalanced forces are getting transferred on the entire bike. You can feel shaking vibration of your bike. Just switch on the bike, start it, and inside some part is reciprocating, entire bike vibrates. Till what time? Till the time your machine is running, till the time engine is on. Clear hai ye baat? Sir, how to balance this? A student is saying, sir, I don't know how to balance reciprocating masses. Rotating masses ko I can balance. So one student said, sir, forget about this mass m. If I just see that on this shaft, which is rotating with omega, here some force is acting mr omega square cos theta. Looking at this force, I am getting a feeling, I can also treat this as that, sir, it seems that some mass r distance pe I have some mass, m mass, r distance pe omega speed se it is rotating. So mr omega square would be its centrifugal force, and that centrifugal force ka cos component, because crank has traveled by theta angle, so its cos component is mr omega square cos theta. This is not the reality. This force is not because of its cos component. Because of this inertia force, mr omega square cos theta I am getting here. But sir, for a moment if I forget this thing, I am just seeing this, I am feeling it, that it seems that this force is because of some forces component. Not a bad thought. Imagination hai, pure wild imagination, है ना? But not a bad thing to think of. And once you can see that a mass is rotating, then we can think of balancing this. How to balance this? Sir, if you can see m mass is rotating, so on the same shaft, just backside may connect something. Here, connect something. Some mb mass, rb distance pe, same shaft pe you have connected, so it will also rotate with omega speed. Balance it, and its centrifugal force, this centrifugal force will be how much? It will be mb rb omega square, and its component, sir, its component will be one in this direction and one component will be in this direction. Sir, you are saying that this component will completely balance this. Completely balance this. Or bhaiya, if this is angle theta, so this angle is also theta. So its cos component will completely balance this. If you have done complete balancing, this mr omega square is same as mb rb omega square. If mr omega square mb rb omega square like this, if you have done, so its cos component will completely cancel this. Hogi balancing, sir. But you forgot that this is real force. You have connected some real mass, its sine component will also come, and you cannot say कि its sine component will be balanced by this. No, this is not a real thing. There is nothing sine component of this mass. So if you try to completely balance this horizontal part, so horizontal will get cancelled, no doubt, but vertical direction where you are getting a force which is unattended, this remains in the system. You will get mb/rb omega square sine theta. Sir, mb/rb omega square cos theta, if it's completely balances, this will remain in the system. And what does it do? Your system was reciprocating, your system was feeling this vibration like this. Engine ki wajah se your system was vibrating like this. Now if you have completely balanced it like this, so horizontal mein shaking force is gone. Now vertical mein we have got a shaking force. Now the same engine is shaking in the vertical direction. And what is the unbalanced force ka amplitude? mb/rb omega square, same as mr omega square. So whatever amount of force was here, same amount of force you have transferred to the vertical direction. It is not good. An idea came. A student said, sir, let's not do complete balancing. And that's why we don't go for complete balancing. We never do complete balancing. What do? We go for partial balancing. What is the meaning of partial balancing? Sir, partial balancing of primary unbalanced force. Careful. Partial balancing का मतलब है let's not completely balance, 100% balancing नहीं कर रहे हैं. I am doing 30%, 40%, 60% balancing. 60% balancing का मतलब होता है that sir, mr omega square completely, if you are balancing this entire mr omega square, if you are balancing with mb/rb omega square, so we will write it like this, that this force is completely equal to this. But I'm saying some fraction of this I'm balancing. 30%. 30% का मतलब हो गया 30% like this, 0.3 times. 60%, 0.6 times, है ना? So C fraction we are balancing. C fraction. अच्छा, omega square gets cancelled. So can I write omega square gets cancelled? So C times mr is equal to mb/rb. And what is this C? C is the fraction. This value is something between 0 and 1. 0 means 0% balancing, 1 means 100% balancing. So C is fraction. How much fraction we are balancing? What will happen? Sir, even if you have done partial balancing, so after doing partial balancing, what will happen? Sir, now I'll have a small force. It is not same as this vector. This vector is quite big. So this force is small. And obviously about that, its horizontal component will be small, vertical component will also be small. So sir, this small component is not completely balancing this. Obviously about that, it will reduce the amount. This force was this big, opposite direction may we have a small force, so resultant I will get some small force, and vertical direction may also I will get some small force. So instead of shaking like this, now horizontal may it shakes like this, and vertical may we have a small force. Getting my point? So this is a relief situation for me. Examination mein they ask question that even after doing partial balancing, some unbalanced force is remaining along the line of stroke and some perpendicular to the line of stroke. Try not to say horizontal. Try not to say horizontal and vertical. Try avoid saying horizontal, vertical. Why I am saying this? Because whenever I have a vertical engine, so along the line of stroke is vertical. Perpendicular direction when new force comes, that will be horizontal. Diagram which I have shown here, line of stroke is horizontal. So horizontal, vertical doesn't make any sense. You must say remaining unbalanced force along line of stroke after partial balancing कितना हो जाएगा? It will be mr omega square mr omega square cos theta was the force minus mbrb omega square cos theta. And mbrb ko can I write c times mr? So put cmr. It becomes cmr omega square cos theta. So you can take common mr omega square cos theta. Inside I'll get mr omega square cos theta common. Inside I'll be getting 1 minus c. Yes, beta. 1 minus c. So this force is still remaining along the line of stroke. And some remaining unbalanced force, or I must say unbalanced force newly developed perpendicular to line of stroke is how much? Sir, it is mbrb omega square sine theta. This is the new force. And instead of mbrb, I can write c times mr omega square sine theta. Examination, they will ask question on this. Tell me how much force is along the line of stroke remaining. Tell me perpendicular direction में how much is the force, and perpendicular direction में this force का amplitude cmr omega square. This is called as hammer blow. Maximum force is called as hammer blow perpendicular direction में, है ना. Direct formula based questions examination में they will ask from here. Nothing new, direct formula based question, है ना. So I just have introduced how diagrams look, how reality में some machine components, which machine components are example of same plane में masses are rotating, different planes में masses are rotating, or reciprocating masses, है ना. So practicality से I have just connected you. Now what we are doing, we are just playing with the forces, vectors, vector summation. That's it, है ना. Not much PYQs you will find, है ना. Just after studying this, go through the PYQs. 4, 5, 6 PYQs you will find, all formula based, and try solving this. If you have any problem, you can ask me, you can connect with me. Where you can connect with me? Here in Vishvajeet sir PW. This is my Telegram group. You can connect with me, you can ask any question related to your GATE preparation subject. ठीक है, चलिए. So that's all. That was all about if masses are rotating, if masses are reciprocating, so they will be producing some unbalanced forces. And we have seen the rotating masses ko still we can think that I can do complete balancing, but practicality ki वजह से I will stop, है ना. Some unbalanced force still remains. Cooler में, washing machine में some rotating masses are there. Company has already balanced, up to their best they have already balanced, but still you can feel some vibrations are there. Why? Because some unbalanced force is still remaining. If company wanted, they can further investigate how much force is there, they can add some balance masses, they can further do this, but unnecessary, it will increase cost of the system. So company says ki theek hai, this much vibration people can handle, this much vibration my machine can handle, and it is not much affecting my running life of the machine, so let's go with that. Reciprocating masses mein I have seen ki even if I want, I cannot completely balance it because of the some conceptual reasons what I have just shown. So we have seen that doesn't matter how hard you try, some unbalanced forces will be there in the system, and if unbalanced forces are there in the system will vibrate, and if system vibrates, so it affects your system badly. So tomorrow when we will meet sharp at 8, I will discuss what is vibration, how does it look, how it affects your system, है ना. What are the parameters which we have to take care when we are studying the vibrations, everything we will discuss. Clear hai? Vibration is a big topic. Natural vibration, damped vibration, forced vibration, vibration isolation, and every topic is very, very, very important from the point of view of GATE examination, especially natural vibration. So that's why I have dedicated 3 sessions for vibration chapter. Tomorrow we will meet and we will talk about what is natural vibration. Okay, so be on time. Sharp 8 PM we are going to meet. Till that time, thank you, bachcho. Goodbye. Love you all.